This is the third part of our lecture on basic Bible geography. And as I've titled it here, we're going to deal with basic geology and climate. Those are the two issues. And again, there's a good deal of review here, but it's all very important. I want us to give just a few minutes to it. First of all, with regard to geology, the basic geology of the land, the Eretz Israel, the land of Israel. And let me say going in that I know very little about geology. I don't call myself any sort of an expert. There are some basic elements of the geological issues and so on that I have been taught and I've included in the notes. And by the way, you do have I've reverted here to the printed notes, and those are available to you on Moodle. Under the stateside video lectures, and we're on page 16. It might be good to have those open, but get these basic ideas. In Israel, the basic sort of rock or type of rock are limestones, and limestone is not igneous, it's rock which has been laid down in sediments or layers. It's stratified rock. I am convinced that as the flood waters receded after the great universal deluge in the days of Noah, that layer after layer of sediment, soil, and rock and so on were laid down and compressed and produced these limestones and sandstones, which really dominate Israel. And when we walk about Israel, we'll be thinking about these limestones, except in Galilee. I'll come back to that. In Galilee, the area around the Sea of Galilee, and especially to the east of the Sea of Galilee, the Golan Heights, is an igneous rock called basalt, very distinctive. But so the chief type of rock is limestone. It is stratified. Geologists refer to various types of limestone, and they really have in mind evolutionary time periods when these supposedly developed. We're going to reject that idea of these time periods, billions of years or millions of years. I am a young Earth devotee, advocate, freak, one might say. But the words that are used virtually universally to describe the various types, the limestone had very distinctive types of limestone, each of which has very distinctive characteristics, are these, and we'll use these. There's no escaping it. I make the point here in this chart that in the first place, there is a non-sedimentary igneous rock called basalt, very black, very hard, very distinctive, that we will encounter when we are up around Galilee. And the building, the way you build with basalt is different. Basalt is very hard. It can be carved, but it's more difficult. And it's very, very good for implements such as millstones and so on. So we'll spend a good deal of time up there and get to know basalt. But returning to the issue of the various limestones, there are regions of Israel which are the land that we're going to explore, which are dominated or composed of these various types, and the shape of the earth and the way you build and the way roads are laid out and so on are very much a feature of each of these types of limestone. So we'll take just a minute. First of all, there is Eocene limestone, which is, for our purposes, the Shfela, this region of rolling hills, undulating hills to the west of the hill country in the south, Judea, and between the hill country and the Philistine plain. So important, the Shfela, it's a buffer zone for Jerusalem. You have to attack from the west, and it absorbs these low hills, absorb the water. So the Philistine plain is much more well-trained and so on. We've talked about this. And the point is that this is very soft limestone. It erodes, thus the undulating hills. It washes away, as opposed to hard limestone that doesn't wash away. And so you have these steep hills and so on. And the other point we made here is that it is very chalky and is very, very good for making mortar and plaster. The lime that they use to line their cisterns to keep them from the water from leaching out and so on, and then the plaster that they use to cover their walls inside and out and so on. So Eocene in the Shfela, and very important, it is open. Get to know that. By open, it means you can put a road most anywhere. That's the point, that it's easy to lay out roads. All right, so that's, and as this Phelan, we will follow the diagonal road that just cuts across because that's where people wanted to go. So you have Eocene limestone in the Shvela, then you have Senonian, and that for our purposes is east of Jerusalem on the Jeshimon, that wilderness area, that area that is baked by the hot easterly winds that blow across the Dead Sea, and they're blowing out of the east, west toward the sea, to be sure, toward the Mediterranean. But this area is very, very rough. Senonian limestone does not use to build, is not good for building. By the way, not only the Jeshimon, but the Mount of Olives, just immediately east of the city of Jerusalem, identified 3 times in the Old Testament as the mount which lies on the east of Jerusalem, separated from Jerusalem, the city of David, the Temple Mount, only by the Kidron Valley. And it's always been covered with graves because it's the perfect spot to dig graves because of that chalky limestone, but it's not good for building. So it's never been built up over much. Again, the communication is good unless there's any sort of a pitch, and then it erodes so easily and so on. So again, the Senonian, it is important that there are strips of Senonian limestone in between regions of hard limestone, and that's what produces these chalk passes that become so important down Carmel and down in the Shvela and so on. So much of the travel, especially there through the Mount Carmel, is a function of these passes that were composed one reason or another, and the way the earth was formed as the waters of the flood receded. There were these bands or regions or strips of Senonian limestone that did in fact wash away and thus produce these passes that are so strategic to making your way in and out of the Jezreel Valley. So Eocene in the Shvela, Senonian in the Jeshimon, the Mount of Olives, and then Cenomanian is the standard hard limestone, does not erode, and yet it's soft enough to frame and shape, and so it's very, very good building material. And the ashlars that Herod used, for instance, to construct this huge temple mount in his palace and so on, in large part this hard Cenomanian limestone quarried out of the side of these steep hills and used for building. So it's very good building material, and but it is very closed. If open means you can build a road anywhere, closed means it's very hard. And in the Cenomanian area, that is in the steep hill country, again, it's hard, so it doesn't erode, so you get these jagged hillsides that are so hard to travel, you can't take a cart up and down those. And furthermore, so you have to stay up on the ridge. So the travel in the hill country is going to follow those ridges. We'll talk more about that later on. So just to make the point, and told you everything I know, and I may have made a couple of things up here, but there are these different kinds of limestone. Limestone is the dominant sort of rock of which the land of Israel is composed. It's a stratified rock, but there are different sorts of it. Some of it soft and chalky, erodes, produces open areas, and most of it very, very hard, doesn't erode, produces difficult hillsides, and travel is restricted to the ridges at the top, very difficult. Now, there are several geological issues and so on that have to do with the way the substructure, the subterranean earth of the land of Israel is formed. I don't know much about it, and to be frank, sometimes what the geological formations are not immediately reflected in the actual topography of the surface because of the way soil is settled and so on. So geologists point out that there is faulting, which shapes the earth. There is folding, where you have upthrust. Faulting is obviously where you have clefts open up or strata, plates move and so on. Folding is just where the earth is thrust up in various fashions. And I do have this note right here that I'm going to stop on real quickly, that there's much debate as to how such folding, how these geological subterranean formations developed and so on. And I believe it was because of catastrophes, primarily the flood, earthquakes, and so on since then. But it's not the result of millions of years of slowly depositing and shifting and so on. That's the evolutionary approach, and that's reflected in these names, which actually represent time periods. But aside from all that, the phenomena that we do encounter in the earth, I think could be best explained by catastrophes. Now, here's I'm going to stop here and slow down just a little bit. This is quite a simple concept, but it's hugely important, and it has it can have very practical ramifications, and it's happened to us a couple of times in Israel. So I want you to think about these arches. Now, an arch, what we're talking about here is subterranean geological rock formations well under the earth, dozens and scores of feet beneath the earth, but hard ridges of impenetrable rock. Impenetrable meaning that when the water percolates down through the earth in this water, when it hits these arches, because it can't penetrate, the water is going to flow in one direction or another. And there are these two primary arches. They tend to lay basically north-south, a little northeast to southwest. And these subterranean arches determine ultimately the direction of the rainwater. Now, the issue is that the watershed on the surface, so the water may be pushed toward the Mediterranean on the surface, but as it percolates through the earth, it actually hits these ridges and is directed back toward the east. I'll show you that in just a moment. So there are these two primary arches, and I'll show you on a map the Ephraim Arch and the Judean Arch. And so here they are. And this is really an important concept. I want you to think about it. I think you recognize the map here. But these are the two arches, the Ephraim Arch and the Judean Arch. Now, again, they are subterranean. They're beneath the earth a good bit. But here is the basic line of the ridge route, which is sometimes called, appropriately, the watershed ridge. And the thought is that as rain comes, remember, most of the rain's coming this way, and as it falls, if it falls to the west of this superficial, that is on the surface, this is the watershed ridge. And so water which falls to the west is going to flow toward the Mediterranean. But the problem is that as that water percolates into the earth, much of it, and comes to these ridges, that same water is now going to be diverted to the east. And this is why when rain falls up in the hill country, and it's bone dry or perfect, almost entirely dry down in the Jordan Rift, but as a little while after the rain falls on the western side of this watershed ridge, as the water percolates down and hits those arches, those subterranean arches, it's diverted, and all of a sudden great torrents of water come bursting out of the side of these hills, and they produce these torrents of water in these otherwise totally dry riverbeds called wadis or nahals. And the fact is that this water, it comes gushing out suddenly, pushing great boulders along and so on. It wipes out bridges, it wipes out roads, and as I mentioned, there have been a couple of times. One of them in 2013 with the Israel Initiative trip. We had left En Geb, come down here to Beit Shan. We were on our way down, went to Jericho, and we were going to go down here to Masada, but we were stopped here. Now, it was dry and pleasant where we were, but over on the western side of the watershed ridge, it was raining, in one case snowing, and all that water soon enough came bursting out of the side of the hills and wiped out the bridges. And we never got to Masada. We were supposed to stay there that night, but we knew if we got down there and those bridges were wiped out, we were going to be stuck there for 4 or 5 days, who knows how long. So we had to detour and go up to Jerusalem and never did get down to Masada one trip. So I'm just saying that the dynamic of these subterranean ridges has a huge impact, because these ridges divert the water which had fallen to the west of the watershed ridge topographically, but now that same water is diverted underground to these underground rivers and comes bursting out the side of the hill in the Jordan Rift. So very important, this concept of arches. Well, that's about all I have to say about geology, some important concepts, but let me take you to issues of climate here just real quickly. And a lot of this, once again, we have already talked about to one degree or another, but I'm going to get back to the top here. I've worked through this before, so let me erase some of this. But the point is, we're talking about these various seasons in the land of Israel. So again, it's not brand new to you. Page 20 of your notes, but let me talk about it. The point is often made, for what it's worth, and it's helpful a bit perhaps, that the climate of Israel is much similar to Southern California. And the reason is that just as LA, Santa Clarita, where we lived for a lot of years, lies between the desert and the sea, so Israel lies between the Arabian Desert and the Mediterranean Sea. And these two very, very different systems or climatological regions hugely influence the climate of the land of Israel. So here are the point. You have these two major seasons. We've talked about this. I'm going to one at a time. First of all, there is the summer dry season, about May to September, during which there is virtually no rain. Now, Barry Beitzel, in his Moody Atlas here, fine, important work, spends a good deal of time explaining the frontal systems and the depressions and air masses and over the whole, that part of the world and so on that affect this. I don't understand much of it. You can read it right here, but notice what he says. Because of that, he's talking about the summer, the dry season, and the climatological factors, the climate of the region produces, number one, and there are a couple of results, and this is what I want to see. Number one, it produces uniformly clear daylight conditions. So the summer is very clear with haziness in the morning and so on. But very importantly, it prevents the formation of rain clouds, even though you have high humidity. So you've got high humidity, you've got a heavy dew that moistens the earth in the night and so on, and is sufficient to nurture and grow the hillside crops, but you don't get rain. And so he says that if there's one word to describe the weather in Israel in the summer, it's stability. Every day is about the same. As a matter of fact, as he says in this paragraph, I'll say it very quickly, that every day it's hot early. The air is very still in the morning, but then it gets it gets warm, and it stays within about 5 degrees for 7 or 9 hours. You don't have much. It's hot early and long. On the other hand, as the air over the sea, so again, you've got the Mediterranean Sea, then you've got the land, and you've got the sun beating down on that land, and pretty soon the air starts to rise. And as it does, you get breezes off the Mediterranean that are, number one, to die for, they're cooling, and number two, they're moist, and that's what lays down the dew. And that's the point that he's making here. The heating of the land triggers the sea breeze, the breeze coming off the Mediterranean. Every day, the cool, that would be damp air, moves eastward from the Mediterranean Sea across the coast to refresh the land and hold the temperature somewhat steady. It doesn't get real awfully hot. It can, but it's quite a moderate temperature. All right, so the prolonged heat of a summer day is the most characteristic feature, but he goes on to say it's not as awful as you might think. Well, and this is what we've already said, the daily wind off the sea, these displacement breezes that, because of the hot air rising, lays down a heavy dew, and I've read we're about 75% of the time, about 75% of the land reaches dew point. And therefore you can grow, the moisture is sufficient to grow grapes and olives and pomegranates and figs and so on. It's also the time when kings go out to war, as you have in 2 Samuel 11, when David didn't go out to war, whether guiltily or not. But the point is that this is when, in the summer, The crops don't need to be so carefully cultivated, nurtured, and watched over as they do in the winter, and the roads are passable because you don't have the rains and so on. So this is what produces a rather seasonal approach to warfare. All right, so that is the summer dry season. On the other hand, the other season of the year is the winter rainy season, October to April. And if there's one word to describe this, it is that it is unstable. It's instability. Now, again, Beitzel spends a good deal of time here explaining the various climatological factors that produce this. But suffice it to say that the winter is the rainy season. All the rain comes in the winter. This is when you grow the grain crops and so on. Days can be chilly, weather is unpredictable. Here is the basic rule, and this is a rule you ought to remember not only as we are in Israel, but as you prepare, as you pack. Cold climate, warm sun. It's really remarkable. We're often there in the summer, and now we're heading for the shade, because if you get the shade, it's tolerable even though the sun is hot. We're there in the winter, very possibly we'll be diving for the sunshine, because it'll be a little chilly. We'll appreciate the sun. This is why you layer your clothing and so on. You'll be taking it off, putting it back on sweaters and jackets and so on all day long, because when the sun is out, it's quite warm. As soon as the sun goes down, it gets quite, it can be very chilly, especially in December. Now again, this is one of the charts you'll see other ones and so on, but notice that this is annual precipitation, rainfall. Jerusalem gets 16 inches. I've seen it placed even higher. But the point is, that's plenty of rainfall. That's plenty. They get plenty of rainfall. The issue is holding on to it. We've talked about that before. All right, now beyond this, beyond these two seasons of the year, the summer dry season and the winter rainy season, there are these two transitional seasons, and these are huge. This is what we called before the former and latter rain. And as it says here, first of all, you have a fall transitional season, which would be the former, or sometimes called the early rains. Remember, Deuteronomy 11 says the land you're going into is not like Egypt, where you watered your crops by foot and you could always depend on it. This is a land which is dependent upon God, and if you obey me, I'll send you your former and latter rain. Well, the fall transitional, former rain, and former because it comes before the planting season. So you need this rain just to get the seed in the ground. So as I say here, this period can come anytime, September, November, usually in October, can take as many as 3 or 4 weeks, but it's a huge shift in the weather system. And so now these hot, dry winds known as the Sirocco wind, the Hamsin or the Sharab, blow off the desert. And whereas we've had the weather during the winter coming off of the, all right, back up. We're coming out of the summer season, but now you get especially hot winds coming off the Arabian desert. It says here they'll force the temperature to rise sometimes 16 to 22 degrees above normal. The humidity will drop. It's a miserable time and so on. And this is the time during this Sirocco season, this transition season, that we look for the former rains. As I say here, these rains are absolutely necessary to Israel's agriculture, and specifically what we're looking for here is the grain crops. So the summer, all through the summer, the sun beats, bakes the ground, and you need these rains just to soften the ground so you can break it up and get the seed in the ground. And again, in Deuteronomy 11, God says, if you obey, I will send you the former rains. By the way, interestingly enough, it's during this season that the Feast of Tabernacles, or Booths, or Sukkot happens. And one of the interesting features of the Feast of Tabernacles, and it shows up in the scriptures, is that everybody in Israel is thinking about and praying for rain, because you need these former rains. And that sort of provides the setting for Jesus at the Feast of Tabernacles in John 7, on the last great day of the feast, when he says, if any man thirst, let him come unto me, and out of his belly shall flow rivers of living water. And that picture is especially powerful at that season of the year. So you have the fall transitional, which is the former rains, and then you have the spring transitional sometime in March or May. In other words, the spring is where you're moving into the summer, out of the rainy season into the summer. again, you have the same Sirocco winds, not quite as dramatic, but it's at this period that you need the latter rain or the later rains, and they mature the grain and so on. Matter of fact, Dennis Bailey, in his Bible geography, really, really an important source. He says, in March, the rainfall tends to taper off, and the final storm usually comes early in April. So we're talking March, April here, though there may be a light sprinkle as late as early May. These latter rains are desperately needed to swell the grain, ensure a good harvest, and their failure is a sign of divine displeasure. So it's interesting that he says here, in actual fact, 3/4 of the rain tends to come in December, January, and February. But so important is the beginning and the end, that is the former and the latter rains, that these former and latter rains are often spoken of as the most significant. All right, then I gave you 6 basic rules for determining, but I always think that if you can understand that if you go south or east or even down as into the rift, it gets dry and hot. All right, so much so for geology and wet and climate.